One of the hallmarks of science is that matter cannot be created or destroyed. It's just converted to a different form. And this is the basis of balancing chemical equations. We have to make sure that whatever's put into a reaction, the reactants, is still there in the same amount at the end of the reaction, the products. Today I'm going to go over with you some specific strategies for how to balance a chemical equation, but before I do so, I want to review some terms with you. When we're talking about a coefficient, that's the number that's written in front of the formula, and that tells us how many moles of the substance is used or produced. These can be changed when we're balancing the chemical equation. However, the subscripts are actually part of the chemical formula and therefore cannot be changed when we're balancing the chemical equation, or it would change the identity of the substance. So make sure that you're only changing the coefficients and not actually the subscripts. Furthermore, there are many types of reactants and products that could be involved in a chemical reaction. The ones that I'm going to discuss are the ones that are the most common, and those include the ones listed here. We could be talking about a pure substance or an ionic compound, which is a metal cation or transition metal with a non-metal anion or a negative polyatomic ion. We can recognize those through certain aspects of their name. I could also be referring to a covalent compound, which is a nonmetal with a nonmetal, or a hydrocarbon, which ends in one of these prefixes. I could also be talking about a diatomic molecule. There's 7 of them that should be memorized, or an acid or a base. The ways that we write and name chemical compounds is beyond the scope of this video, but I will include a link that will go through some specific strategies for how to write and name chemical compounds. Today, however, we're focusing on how to balance a chemical equation. And I have some specific steps written out for you here on the left, and I'm going to go through these steps with you as we complete a problem on the right. I know that it's a little hard to see. Let's see if I can zoom in. I'll probably just have to work with this. Once we get through the first example, I'll go ahead and zoom in on the right so that you can see a little bit better. Our first step with any problem is to read the question. We have aqueous solutions of lead 2 nitrate and sodium chloride that are mixed to form aqueous solution of sodium nitrate and a solid precipitate of lead 2 chloride. Our first step when we're writing and balancing a chemical equation is to write the unbalanced chemical equation by listing out all the reactants and products. Notice that I left space before each compound, and I also put plus signs to separate them and an arrow to separate the reactants from the products. That's what step number 1 is. Step number 2, we're going to list all the reactants, all the elements that are in the reactants on the left, and write those in the same order under the products on the right. There is a shortcut to this. If you do see a polyatomic ion, like I do here with nitrate, that does not change from the reactants to the product. That is, it remains intact as NO3. I can do a shortcut and just write NO3 rather than breaking it up into nitrogen and oxygen. That's what step 2 is. Then we're going to use the subscripts to count how many atoms of each element we have on the reactant side and record those, and then we repeat it with the product side. Some things to be really careful of are carbon, hydrogen, and oxygen, because sometimes they're spread out over multiple compounds, and you'll see that in a later example. Once we've written them all out, we look at our numbers to see if it's balanced. Clearly here, my nitrates are not the same, and neither are my chlorines, so this is not balanced and I need to continue on. When we get through the balancing part, our first step is to identify the most complex substance that doesn't have an H or an O in it. So I see NO3, but that has an O. The only other thing that's not balanced is my chlorine. So I'm going to go through the process of balancing it now using whole numbers as my coefficients. In order to get 2 chlorines on the left, I'm going to put a 2 here in front of the sodium chloride, which does change my number of chlorines, but because it's impacting the entire compound behind it, it also changes my number of sodiums. Notice I didn't change the compound, I didn't change its subscripts, I'm only changing the coefficient. Now that my sodiums are not balanced, I'm going to go ahead and put a 2 here so that I can get the sodiums balanced on this side, but again, that also impacts my nitrate. That's a good thing though, because I needed 2 nitrates, and so now we can see that all of our numbers on both sides are the same, which indicate that this is balanced. I kind of zoomed ahead here because I got excited. So with step 4, after we identified the most complex substance that didn't have an H or an O, and we went ahead and crossed off all the corresponding numbers, we then went to the polyatomic. I didn't have to balance any H's or O's in this one because there weren't any listed individually, but I do want to point out that if there is an H or an O listed, you want to do the H second to last and the O last. Those two tend to present some problems, so saving it for last kind of fixes itself if you go in that order. Let's go ahead and take a look at the next example. I'm going to zoom in over here and just verbally talk you through the steps. So first we read the problem. We have solid magnesium, aqueous hydrochloric acid react to produce aqueous magnesium chloride and hydrogen gas. I've written everything out here, leaving myself space for me to put the coefficients. I've also listed out all of the elements for the reactants in the same order I wrote them under the right side of the products. Then I used the subscripts to count how many I had of each. Looking at this, I can see that my hydrogen and chlorine are not balanced, so I need to go through the process. I would identify the most complex element that does not have a hydrogen or an oxygen in it, and that would be chlorine. So I'll go ahead and put a 2 here. That changes this to a 2, and it also impacts the hydrogen. Thank goodness, because now I'm balanced. You can also double check by looking at the equation itself, seeing that you have 1 magnesium on each side, 2 hydrogen on each side, and 2 chlorine on each side. That was a pretty easy example. Let's get into one that's a little bit trickier. If I have the combustion of heptane with oxygen to form carbon dioxide and water, which is what a combustion equation is, my equation would look like the one below. I would then list out everything I have under the reactant side, everything I have under the product side in the same order, and then using the subscripts, I count how many I have of each. I want you to be aware that the oxygen on the product side is a little tricky because I have 2 in the carbon dioxide and 1 in the water for a total of 3. Our next step is to identify the most complex that doesn't have an H or an O. That's going to be carbon. So I'm going to put a 7 here in front of the carbon, which changes this to 7 and also impacts the O. That means I'm going to now have 14 for the carbon dioxide and 1 for the water, giving me a total of 15. That's okay, it looks a little weird, but we're saving oxygen for last anyway. Let's deal with the hydrogen next. Since I have 16 hydrogens under the reactants and 2 under the products, I'm going to put an 8 here so that I can end up with the 16 that I'm desiring. And now my carbons and my hydrogens are balanced, but remember that 8 on the water also impacts the oxygens. So if I have 14 for the carbon dioxide and 8 for the water, that gives me a total of 22. Now all I have left is the oxygens to balance, which is pretty easy. If I just put an 11 here, changes that to 22. And then I look back at the equation and just see if everything is in order. This is one of the reasons why it's important to save oxygen for last, because oxygen is a troublemaker. So hydrogen and oxygen for the last 2 is a good tip to walk away with. What I want to do now is go over some of the more complex ones and some troubleshooting methods for how to deal with them. Because there are some cases, as I just said, where oxygen causes a lot of problems. So we have 2 different methods for when we have problems with oxygen. If oxygen is showing up in multiple compounds, it can often prove difficult to balance. So we have 2 methods for how to deal with it if we start spinning around and can't seem to get to the final answer as easily as those last examples. Method number 1, we would just go ahead and double whatever coefficients we have currently. So if we balance all the other elements and we find that a coefficient of a fraction with 1/2 would balance the O's, then a strategy would be to double all the current coefficients and then to finish balancing. Let me show you how we would use method 1. In this first challenging example, we have solid iron 2 disulfide that reacts with oxygen gas to form solid iron 2 oxide and sulfur dioxide gas. I've written everything out here with spaces and pluses and the arrow. I've also listed out all of the elements that are in the reactants and products in the same order, paying special note to the fact that there's oxygen in 2 places on the products to give me a total of 5. Now I'm going to identify the most complex substance that doesn't have an oxygen or a hydrogen in it. That could be sulfur or iron. I'll go ahead and just start with the iron because it's listed first. So I'm going to put a 2 here. That changes how many iron I have and also how many sulfur I have. Once I do that, I see that my sulfur are not balanced, so I would put a 4 here. That changes how many sulfur I have, and it's also going to change how many oxygens I have. If I have 8 there and 3 over here, that gives me a total of 11. Now I'm reaching the situation where if I was going to have to use a fraction to balance the O's, I know that I could use method 1 instead. So for method 1, what I would do is actually double the coefficients I currently have. So I'm going to go ahead and double this one to a 4 and double this one to an 8 and make the necessary changes below. So that tells me I have 4 iron and 8 sulfur, and that over here tells me I have 8 sulfur, and I have how many oxygen now? 16, so I have a total of 19. Since my iron is not balanced, I'll go ahead through that process. I'm going to put, I guess I didn't mean to cross off that before, but we'll cross it off now. I'll put a 2 here. That gives me a total of 4 iron. And if I have 2 in front of there, that's a total of 6 oxygen with that one, plus the 16 I have on the other side. That gives me a total of 22. Now balancing the oxygen is pretty easy. I put an 11 here. That gives me 22. So when we got to the situation where we needed to balance the oxygens with a fraction, a strategy is to double the coefficients that you currently have already changed and unravel and finish balancing from there. There's also another method we could use. If we balance all the other elements and you find that you have an odd number of oxygens on one side and an even number on the other side, we can increase the coefficient of one compound that does not have an oxygen by 1. I could have used that method here, but I'm going to show it to you in the next problem. So let's take a look. I'll keep this one close by. All right, if we have a problem that involves the combustion of butane with oxygen gas to form carbon dioxide and water, the equation is as follows with all of the pluses and the arrows plus everything listed out. Watch out for that oxygen. This is a warning that this might be a more challenging problem, the fact that oxygen is spread over multiple compounds. I'm going to start by balancing what doesn't have an H or an O with it. In this case, it's the carbon. So I would put a 4 here. That also changes my amount of oxygen. I have 8 plus 1 more, that's 9. Next, I would try to balance the hydrogen. If I balance the hydrogen, I would try putting a 5 here. That would give me 10. So if I have 5 oxygen for the water and then 8 more, that gives me a total of 13. My carbons are balanced and my hydrogens are balanced. The only problem now is that oxygen is even on one side and odd on the other, kind of like I had last time. So I could try using the strategy from before, but I want to show you method number 2, which is to increase the coefficient of one of the substances that doesn't have oxygen by 1. The only substance that doesn't have oxygen here is butane, and its current coefficient is 1, so if I increase it by 1, I'm going to change it to a 2. Let me go ahead and make the changes that would be resulting from that new coefficient, and then I'll go through the process over again of balancing, again starting with the carbon. So I would change this to an 8 as well, which gives me 16 plus 5, so that's 21 oxygen. My hydrogens are not balanced, so I'm going to go through the process of changing those. I want 20, so I'll put a 10 here, which gives me the 20 I want. And then altogether I have 26 oxygen now. And as the final step, I would put a 13 here to give me a total of 26. So you have two methods for how to deal with a situation where oxygen is the only one left and it's not working out for you. One is where you would just go ahead and double the current coefficients and finish balancing. The other is where you would increase the coefficient of the compound that doesn't have an oxygen in it by 1. Sometimes you need to use a combination of those, or you might need to use the method more than once to get to the final answer, but both of those are good starting places. Thank you for watching the tutorial. I will have links to other guides and tutorials in the notes at the bottom, and I'll also have links to how to name compounds as well.